In this logarithmic equation, you can see that we already have some things that are going to be quadratic, which means there's the potential for getting two solutions. We have to make sure that we check these guys. Now, this is just like the last problem that we did. We've got variables inside the log, and we don't want them there. So we're going to fly the plane to turn this from something that's logarithmic into something that's exponential in hopes of getting something that is workable, right? So that means 4 to the third is equal to x squared minus 12x. All right? Well, 4 to the third, I do know that because I've got my list of powers. That's 64. And since this is quadratic, I'm hoping that I can factor. Let's see. Move the 64 to the other side. We get 0 is equal to x squared minus 12x minus 64. And are there factors of 64 that subtract to 12? Well, when you think about it, yes. There are two numbers that multiply to 64 and subtract to 12. And those factors happen to be 16 and 4. If you don't know that, you know that you can go through systematically and work through all the possible factors of 64, and you would arrive at 16 and 4. This would be a negative 16 and a positive 4. And as we finish solving this quadratic equation using the zero factor theorem, that means x equals positive 16 or x equals negative 4. Now before we go run off and tell our friends that we've got our solutions, take the time to check, right? Now there really shouldn't be any issues with either of these guys. If I plug in 16, so you know what, let's just make things a little bit easier for us. Don't tell anybody that I'm using a calculator here to help you guys. Let's plug in 16. If I do 16 squared minus 12 times 16, we get 64. And we know that log base 4 of 64 is going to give me 3 because 4 to the third is 64. That guy checks out. The other solution was negative 4. So if I do parentheses, be careful with the parentheses, negative 4 squared minus 12 times negative 4. I also get 64, which I know is what's supposed to be in here, so that 4 to the third gives me 64. So both of these answers are correct. There are two solutions here. Again, the calculator didn't do my work. I used it to check my work. My work was valid, and I was able to back that up using the calculator. Now let's look at this next example. This next example has a little bit of work for us to do. See, right now, I don't have a condensed log. I have two separate logs. But one of the properties that we had is that when you have addition, the addition of logs can come together as the product inside these two logs. So we can say log of the product x plus 4 times x minus 5. And this is equal to 1. And once we do this, it's very similar to the last question that we just did. But you need to understand that this is understood to be a base of 10. And as a base of 10, we're going to turn this into something that's exponential. So that means that 10 to the first is equal to the expression inside the logarithm x plus 4 times x minus 5. And so now we have to work this out. 10 to the first is 10. And I need to FOIL this. I get x squared minus 5x plus 4x and minus 20. So I see it's quadratic. Again, I'm hoping that this is something that factors. So let's move the 10 to the other side and see what we get. So combining like terms, we have x squared minus x minus 30. And we think about factors of 30 that can subtract to give me 1. Those factors would be 6 and 5. So this trinomial factors as x minus 6 times x plus 5. All right, well, we're almost there, right? Finish solving, we get x is equal to positive 6, or x is equal to negative 5. And before we can box these answers, we've got to check. See, we mentioned earlier that with logarithms, this expression has to be something that's positive. That means you can't plug in a value of x that's going to make it negative. Well, look at 6. If I plug in 6, okay, what does that look like? So if I check that guy, I would have the log of, let's see, that's 6 plus 4 is 10, plus the log of, plug in 6 here, 6 minus 5 is 1. Knowing how common logs work, log of 10 is 1, log of 1 is 0, and I get 1. So that guy checks out. X equals 6 is a solution. What about x equals negative 5? Well, here's the thing. If I plug in negative 5 here, and I try to check this, I end up with the log of negative 5 plus 4 is negative 1, and I get the log of negative 10 when I plug it into the other log. Unfortunately, these guys are undefined because you can't take the log of a negative number. Now here's the difference between this problem and the first one. In the first problem, my quadratic was already established being inside the logarithm. So it's going to be pretty easy for both of those solutions to work. Down here, I didn't have my quadratic until I used a property of logarithms to bring them together. But this piece right here already has certain restrictions. For x, x has to be greater than negative 4 so that we don't have issues. And over here, x has to be greater than positive 5. So that means any value of x that I try to plug in as a solution has to satisfy both of these, which means it's got to be greater than 5 because that's the more restrictive of the two, which meant that x equals negative 5 was never going to work because, well, it doesn't satisfy either of these guys. Only x equals 6 is greater than 5 and it's greater than negative 4. All right? So even though these solutions are perfectly fine for this equation, you always go back to the original to check, especially when we're talking about logarithms.